we are going to discuss isoelectronic point and electrophoresis process. We will discuss out what is the meaning of isoelectric point and the electrophoresis process, what would be the equations and other parts of the other important parts of isoelectric points. So let's start our journey today. So basically, by definitions, isoelectric point is equal to pH at which there is no net charge. That is, the pH of an amino acid which have any net charge is called isoelectric point. That is, it's a point of amino acids which is in terms of pH which does not have net charge and does not migrate in electric field. So it is denoted by Pi. So as you know, if it is positively charged cation, then it will move towards the anodic field in an electric field. Similarly, if a molecule is negatively charged, it will migrate it towards the cathode. And if the molecule is a neutral one, it can't be moved from anywhere. That is, neither it will move towards cathode nor it is moved towards the anode. So basically in amino acids, either it will be positively charged or it will be neutral, plus minus will be 0, or it can be in the negative one. If it is negative, then it will be high pH, and if it is positive, then its pH should be the lower. That means this particular molecule, when it is a neutral one, when it got protonated, it will be in acidic medium and hence it will have a lower pH value. I will discuss it later. If it's around 10, it will be basic. Around 5, it is the neutral, and around 3, it is the acidic in nature. So whenever any compound having Pi around 3, it will be an acidic in nature. So commonly, if it is Pi is near about 5, it is a neutral. And if I say if a compound Pi is around 5 at pH value 2, which side it can be moved? Let's say, let's find out which side. That means either it will be cathode, it move towards cathode, or it can move towards anode. So if Pi value is greater than pH, it will move towards the cathode. Since Pi value is greater than pH, means it is slightly positive, and hence it will be moved towards the cathode. Cathodes are negative. Similarly, if the pH is neutral, that means its value is 5. When pH is 2, and if the pH goes decrease, it gets acidic or protonated, and hence it will be positively charged, and hence it moves towards the negative one, and this is the cathode. Similarly, if the pH of its solutions is greater than Pi value, it will be just reverse, since it's more since it Pi say around the 5, and if pH is greater than Pi, it will be basic in medium, and hence it will remove the H plus of NH3 and leads to the negatively charged, and hence it will move towards the anode. So here is the way. Here it is the neutral one, where the plus and minus is almost 0, plus 1, minus 1. So here it is the NH3 having the positively charged, COO is a negatively charged, which is the neutral form. When it gains a proton, that is the acidic medium, low pH, it is the positive, and hence this one will be moved towards the cathode. And if it lose out a hydrogen from here, then it will be NH3 and CO minus. Since this one is a minus, so it will be moved towards the anodic one. Thus, the value, if say that it is a neutral one, its value say it is 5. So its value say 2 since lower pH. So Pi is greater than pH. So acidic medium, positive, move towards the cathode. If it is 5 and its value is greater, that means pH value will be higher, say around 7 or 8. That means it is the basic medium, and hence it will be negatively charged, and hence it moves towards anode. Okay, let's move to the next slide. Yeah, and so in the just conclusions at very pH below pK, the amino acids have the overall positive charge, and if it is having it will be negative charge. So basically, always the to find out the pK value, I have to plus out the pKa and pK2 values and average out the both. So here let's consider one example. It's a COOH, one group is COOH, another one is NH3. So that means acidic group and one basic group. That means number of acid and basic groups are same. Due to presence of same number of acid and base, equal number of acid and base, it should be a neutral one. If it is a neutral one, say its pK value is near about 2.34, while for NH3 its pK value is 9.69. Hence, to calculate out Pi value, I just find out the average of these two values, that is 2.39 plus 9.69 plus divided by 2. Okay, so here is the way, and the value is find out to be 6.02. Similarly, if it is in acidic medium or in acid side chain, say here it is the one which is the lower the value, that's pH, or it can be having more than one group. It is having the two groups of carboxylic groups, so hence it will be acidic one. So here what I have to find out is that calculate out the average of these two carboxylic groups. One is this one and another one is this one. No need to consider the basic part, that is the 9.69 will not be considered for a calculation of Pi. So first this one is considered as 2.19 and this one is experimentally found to be 4.25, and hence Pi should be average of these two groups value. pK value of these two acidic groups, since it's an acidic amino acids. So for the basic chains, here there should be presence of two NH2 group or higher number of NH2 group compared to the carboxylic groups. So here are a few points for that. So let's find out one example. So here it is. One NH3 groups is here, that is 10.79. Another NH3 groups is here, which is 8.95. And the pK value for the carboxylic groups is near about 2.18. Now let's find out whether it is acidic or whether it is a basic amino acid. So since two number of NH3 groups is here, so hence it should be basic in nature. If it is basic in nature, I have to calculate out both the pK values of the NH3 group, that is 10.79 and 8.95. So average of 10.79 and average of 8.95 will be considered as the Pi value for the lysines. It's a example of lysine. Sometimes there may be question also that from the you have been asked to given the or assign the pK value for the compound. So this value can be given at anywhere, any in the equations, and you have to assign the values. So since this one is a acidic group, so lowest value should be always for the carboxylic groups, and whichever will be the higher or near about 10 approximate range, that one will be denoted assigned for the amino group. But remember one thing, you have to always find out which one is more acidic. So acidic protons will always get the lower the pK value, that is the 8.9. Hence it's an electrochemistry. So here are the few of, that means near about 21 amino acids are possible. So here are a few of them. So let's find out what the questions can be asked. So you have to always find out whether the number of amino groups and acidic groups are equal or unequal. So if it is equal, then it will be called as the neutral amino acids, and if it is having the positive or having the higher number of NH2 groups, it will be considered as the acidic amino acids. So here are a few values SARTs I am just providing for you. Just try to find out the structure followed by pK value, pK2 value, pK3 value. So whichever is be applicable, just find out that. Yes, let's say here it is 2.34. So that means this one should be basically for the carboxylic group. It's near about 10, so it should be basically for NH2 value. So similarly, you just try to find out the value for the others also. If it is aspartic acid, near about the pK value is 1.88, that means it should be the value for the carboxylic groups. 9.60, that means it should be the NH2 group value. And pK value, that means it should be for the carboxylic group, which should be remain. So that's where the way to find out the different PI value. So here I have to find out the average of these and these. So it will be 2.77. Same way, you just try to find out. If you have any problems, just comment me below. I will just try to reply you out. But before that, basically go through my earlier video on structures of amino acids. What are the amino acids? Essential, non-essential amino acids. So these are the parts on which I have discussed the structures. So just go through it. So let's come to the questions now. Common amino acids I just mentioned out here with their respective structure. If possible, you just write down. So arrange the following in increasing order of PI value. Its val means valine, its ars means arginine, so it should be aspartic acid. Okay, aspartic acid, this one. So now let's find out the number of carboxylic groups. So which one will be the acidic now? Which one will be the acidic? First try to find out which one will be acidic. Here, let's find out. Here it is one COH group, NH2 group, and COH. That means in case of aspartic acid, there is two acidic groups. So definitely it will have lower PI value since this one is acidic. So that means its value should be near about 3. Then for arginine, here it is, number of NH2 group will increases due to presence of number of NH2 group higher compared to the carboxylic groups. It must be basic and its value should be the higher end. Okay. And since it is the neutral, its value lies near about 5. So that means the lower value will be for the aspartic acid, then valine, and then arginine. So that means arginine will have higher PI value, and the lowest one will be for aspartic acid based on the structure. So you have to basically know or remember the structure. So only by knowing the structures only we can determine it perfect way to the way. So how to remember, how to draw the structure. So if you have any problem, just go through my earlier lectures where I have just shown how to remember the structures, the lines which have to be used for remembering all the structures I have given already. So just go through it. Similarly, one another questions where you are being asked to match. Just try out this one, okay? The second one I just left out for you people. So whatever the way, you just comment me below. I just try to comment you. And here it is the another one. Match the following with the given value of pi. So let's find out which one will be for these three value. The first one is NH2 CH2 COH. That means one COH group and one NH2 group. So basically it should be a neutral one. So for the neutral one, I think it should be almost each and every one is just follow out. So since it is the neutral one should be approximately this. So here it is one carboxylic group, here it is one another carboxylic group. So basically it should be an acidic. So acidic one will be always having value near about 3. And since this is having two NH2 group, so that means it's a basic amino acids and its value should be near about 10. So it should be the answer. So here it is the aspartic acid will be the highest, and this one will be the. So these are the way how to find out the questions answer. So hope you just find out the proper way to find out the answers. So let's proceed to the next one. So the very next questions, here is a few pK values are given. One is around 4.3, another one is around 9.7. So all the values are given. So you are being asked to find or assign the particular value for the respective groups. So let's find out now. So here it is the carboxylic groups. So two carboxylic groups. So which value should be near either this or this. That means 9.7 should be the for the NH2 group. So now find out which one is more acidic. Undoubtedly this one will be more acidic due to the presence of this NH2 group. So hence 2.2 should be for the CH3COH down the very right hand side, and COH should be the 4.3 for the left hand side. Similarly, you just try to find out the second one where the carboxylic group should be the 2.18 and what would be the next. So acidic one will be lowest, less acidic one will be the higher. So these are the way to find out the proper. You just try to find out this should be a type of questions in your early days. So here it is one part where you are being asked to calculate out why the lysines is the average of pK values of the two protonated amino group since they have the basic amino acids. So asparagine, arginine, serine, you have to ask to calculate out PI. Just go through the SARTs which have already been given. Try to draw out all the three amino acids and find out the PI value for the respective one. What would be the value? Just comment me below. So next question is which amino acids has the lowest PI value? So definitely the acidic one will always have the lowest PI value. Which amino acids has the highest PI value? So you have to mention one basic amino acids. Give an example of basic amino acid. So which amino acids has greatest amount of negative charge at the pH 6.20? So you just calculate out and try to figure out all the equations. Okay. So on the very next slide, I just go. So now let's come to another point, which is the electrophoresis. So electrophoresis is an analytical method to identify the amino acids by observing their migration as a function of pH under an applied electrical field. It is so-called chromatography, and a process of chromatography in applying in presence of an electric field. So the process is based on the principle that charge carried by the molecules depend on the pH of the medium. So here is the few types of electrophoresis. One is zone electrophoresis, where if a subpart hit, it will be paper electrophoresis, gel electrophoresis, thin layer electrophoresis, cellulose electrophoresis, etc. are the part of the electrophoresis process. And another one is the moving boundary electrophoresis, where a few of them are capillary electrophoresis, isophoresis, and isoelectronic focusing, amino electrophoresis, etc. So here it is the part. Here I am showing the two chambers. One is connected to a battery, where this one is a positive, and hence this one is the anodic chamber. This one is negative, so this one is the cathodic chamber. There is a filter paper which is connected from one beaker to the another, and solvent can be flown. And when I will apply the electric voltage or electric potential or electricity, the migrations will be start depending on the charged one, and hence they will be separated out, and based on the separations we can conclude a few points. So point number one, the amino acid is spotted on a strip of paper on the central line, and secondly, the strip is moistened with the buffer solutions given pH. Electrodes are attached to the ends of the slip, and a potential will be applied. Depending upon the amino acidic charge, it will migrate either to positive or to the negative electron. So next, based on the results, the expected results will be either on these 3 points. That is, if the pH of the buffer solutions greater than the pH of the acid, then it will be what it would be, and less than if it is, and if it is, can be equal. So if it is less than pH of the given acid, then I will conclude it out that the amino acid will be in the negative form and will move towards the positive in anode. Okay, so if the pH of the buffer solution is greater than the pH of the given acid, then amino acid will be in the negative form and will move towards the positive end, that is the anode. Okay, the amino acids will be moved towards the positive end, negative end. And if pH of the given acid is greater than the buffer, then amino acid will be in the positive form and will move towards the negative. Just the opposite of the earlier one. And if it is pH is equal to the buffer pH, then it can move to the any directions. Now, what is the movement and all? So here I am showing it is a buffer which is connected to the positive end. Here is the negative. So these are the part for the movement. If the particles are positively charged, it will move towards the cathode. If it is negative, then it will move towards the anode. And that's the way to differentiate the amino acids. So when charged molecules placed in the electric field, they migrate towards either the positive or the negative. And through the migrations, we can conclude out, number one, that influence the electrophoresis mobility, net charge of the molecule, size and shape of the molecule, and the concentration of the molecules in the solutions. So now coming to the other one, that is the application, advantage and disadvantage. What are they? So point number one, the electrophoresis has a very useful application found in blood cell separations. The advantages is that it gives us the knowledge why component of a mixture of amino acids moved in electric field. And thirdly, The disadvantage is that the porosity of commercial paper is not controlled and therefore it is not sensitive nor it is reproducible. So come to the conclusion part. So electrophoresis process proves as extremely useful method for separations of charged particles ranging from small ions to larger ones, and charged macromolecules of biological and biochemical methods. And at last, it is the widely used, but yet it has some limitations.